All right, so we've all played around with AI chatbots, right? They're impressive. But what's the next big step? Well, today we're diving into something called LLM agents. This is where AI stops just talking and starts doing.
So just think about that for a second. What if AI could actually do more than just talk? I mean, what if it could not only answer your questions, but actively get stuff done for you? You know, interact with your apps, solve really complex problems step by step. That right there is the whole promise of AI agents.
So, what is an LLM agent really? Well, at its core, you've got a super powerful language model. Basically, the same kind of brain you find in chatbots today. But here's the kicker. Instead of just chatting, it uses that brain to reason through a problem, come up with a plan, and then actually execute that plan using a whole bunch of different tools. It's an AI that takes action.
Okay, so here's what we've got on tap. We're going to start with the blueprint of an agent, then we'll do a little test run to see how it thinks. After that, we hit a twist, the fixed brain problem. We'll look for some inspiration from an unlikely source, games AI, and finally, wrap up with the vision for the future of agents.
All right, let's get into it. To really get how these agents tick, we've got to pop the hood and look at the main parts inside. So turns out there are basically 4 key pieces you need to build one of these things. The best way to think about it is like you're putting together the perfect personal assistant. You need a brain for making decisions, some tools for actual skills, a memory or a notebook, and a planner, a to-do list, to keep it all straight.
First, you've got the agent core. This is the big boss, the brain of the whole operation. It's the central language model that looks at your request, figures out the next move, and pulls all the other pieces together. It's kind of like the conductor of the whole AI orchestra.
Then you've got the tools. I mean, an agent is useless without actual skills, right? The tools are what give it those capabilities. So this could be anything from searching through a bunch of documents to crunching numbers with a math tool, or even plugging into outside databases and APIs.
Okay, and for any task that takes more than one step, you absolutely need memory. This is basically the agent's little notebook. It keeps track of the conversation, what it's already done, what it's found out. Also, it doesn't get confused or do the same work twice. Honestly, without it, the agent would just be completely lost. And last but not least, the planner. This is the real strategist of the group. The planner's whole job is to look at a huge, complex problem and just break it down. It turns it into a simple step-by-step plan. And that skill, decomposing a problem, is absolutely key to how these things think.
So, we've got the blueprint. Now let's put it all together and see how it works in a real-world example.
So imagine you ask your shiny new agent a question like this. At first glance, it seems pretty simple, right? But it's actually not. It's a multi-step problem. You can't just look up the answer in one shot. You need to find a few different pieces of info and then do a calculation.
And this is where the planner really shines. It looks at that question and instantly breaks it down into a simple, logical plan. Step 1, what was the revenue in Q1? Step 2, okay, what was the revenue in Q2? And step 3, what's the difference between them? See? Now each of those is a simple task it can handle with its tools.
Okay, this whole system seems pretty amazing, right? Super smart, super capable. But here comes the twist. There is a massive fundamental flaw with this entire approach. We're going to call it the fixed brain problem. And it's not just me saying this. A recent paper really hits the nail on the head. It points out that the real root cause of the problems with today's agents is that the language models at their core are, and I'm quoting here, fixed yet imperfect.
So here's the bottom line. The agent can follow the plan perfectly, but it doesn't learn a single thing from the experience. It doesn't matter if it succeeds or fails spectacularly, that core LLM, the brain, stays exactly the same. It's like having a brilliant assistant who, unfortunately, makes the exact same mistakes every single day because they just never learn.
So, if the fixed brain is the problem, how do we solve it? Well, the inspiration for a new way forward actually comes from a place where AI isn't just good, it's literally superhuman, playing games.
I mean, just look at the journey of DeepMind's game-playing AIs. First, there was AlphaGo, which got good by studying millions of human games. But then, and this is amazing, AlphaGo Zero came along and became the best player on the planet just by playing against itself. And Mu0 went even crazier. It learned the rules of the game from scratch, just by playing. The secret sauce here is that constant iterative improvement. And here's the proof in the pudding. The raw brain of AlphaGo Zero was already a beast, with a rating over 3,000. But when you let it plan ahead at decision time, its performance just skyrockets to over 5,000. That's just an insane leap.
It proves that when you combine a model that learns with active planning, you get these truly superhuman results.
So, this all leads us to a whole new vision for what agents could be. The big question becomes, how do we build agents that can actually learn and get better on their own, just like AlphaGo Zero did?
This table really lays it all out. The old way? You have a fixed general-purpose model that maybe gets a big update every few months. The new vision? You build specialist models that are constantly improving through reinforcement learning. And, maybe the most important part, they are built on a solid foundation of ground truth, getting feedback from what is verifiably correct, whether that's from rules or just from interacting with the real world.
And this new way of thinking gives us these awesome new frameworks. You have things like Agent Zero, which is perfect for worlds with concrete rules, like math or coding. Then there's Agent Mu, inspired by Mu Zero, which actually learns a model of its environment as it goes. And even Agent Infinity, which is designed to learn directly from interacting with our messy, unpredictable world.
You know, the shift in thinking here is actually pretty huge. The idea is to move on from what you could call the era of human data, where AI just learns from a static snapshot of the internet. We need to move into the era of experience, where AI learns dynamically by actually doing things in the world. So, if there's one single thing to take away from all this, it's this. For AI to get past being a clever chatbot and become a true agent, it needs a feedback loop with reality. It has to be able to act, see what happens, and then learn from that outcome. It has to learn by doing. And that really leaves us with one last big question to chew on. Maybe the path to real AI isn't just about building bigger and bigger brains. Maybe, just maybe, true intelligence will come from a brain that's simply better at learning from its own mistakes.